Today, we have an exciting project in store for you. In this video, we exciting world of smart home technology with a fantastic project. Creating your very own NodeMCU-based smart doorbell system using NodeMCU and DF Player. You're not at home, but you have a visitor at your door. No worries, with our custom-designed smart doorbell system, you can set a personalized audio file to greet your guest. Anyone who presses the doorbell will trigger the system, replaying your custom recorded message. Just think about the surprise and delight on your visitors' faces when they are greeted by your friendly voice, even when you're miles away. So without further ado, let's dive into the details and learn how to construct this amazing project step by step.
Audio Jungle.
In this video, I'm excited to showcase a unique and intriguing project with you all. As the title suggests, we'll be exploring the next generation NodeMCU doorbell system, NodeMCU and DF Player Edition. In this NodeMCU doorbell system, I've added an additional feature, track selection. This means I've stored multiple audio tracks on an SD card. By pressing a switch, you can change the audio track, and a LED indicator will show which track is selected. This way, you have the flexibility to choose which message is played in different situations. I'll go into more detail about this feature later in the video. This doorbell system is not for homeowners, it's designed specifically for visitors. When you're not home, this doorbell will play a pre-recorded custom audio message to your visitors. So, even when you're not there, this device is not meant to welcome your visitors, but rather to provide them with a message indicating that no one is currently at home. Despite this, the doorbell will still allow your visitors to feel acknowledged and informed, even in your absence. Before we dive into the details of this project, let's take a moment to view a simple animated explanation. This will give us a better understanding of the project before we jump into all its intricacies. So, sit back and enjoy the animation as we gear up for an in-depth look at the next generation doorbell, NodeMCU and DF Player Edition. I present to you a simple animated explanation of the NodeMCU doorbell system. This system comes equipped with a speaker that plays custom recorded voice messages for your visitors. In addition, there's a traditional doorbell in your home. The NodeMCU doorbell system and the traditional doorbell work together, allowing you to choose which one to use based on your situation. For example, if you're not home and a visitor presses the doorbell switch, the NodeMCU doorbell system will activate and play the pre-recorded voice message.
Unfortunately, all residents are currently away from the home. If you need anything, please return at a later time. Thank you.
However, if you're at home, you can turn off the NodeMCU doorbell system and the traditional doorbell will take over when a visitor presses the doorbell switch. This way, you have the flexibility to choose the type of doorbell you want to use, depending on whether you're at home or not. By combining the convenience of the NodeMCU doorbell system with the traditional doorbell, you have a versatile and user-friendly solution for greeting your visitors. In order to build this project, we will need several key components, including a NodeMCU module, a DF Player module, an SD card, a 12-volt 2-amp transformer, a 12-volt DC fan, two 12-volt relay switches, a TDA2030-based mono amplifier module, a bass and treble control module, a rocker switch, two micro push switches, and a plastic enclosure. It's important to note that this list is not exhaustive and only covers the main components. For a complete list of materials, please refer to the video description. The NodeMCU is a crucial component in this project as it serves as the brain of the system. It is a low-cost Wi-Fi microcontroller development board based on the ESP8266, offering a platform for IoT applications. The NodeMCU has built-in support for Wi-Fi connectivity, making it ideal for use in wireless projects like this doorbell system. It controls the DF player and triggers it to play the pre-recorded audio messages, as well as the traditional doorbell. With its simple yet powerful functionality, the NodeMCU is an excellent choice for a project like this, where versatility and user-friendliness are key factors. The DF Player is a compact and cost-effective MP3 player module that plays a key role in this project. It features a simple serial interface, making it easy to be controlled by the NodeMCU. The DF Player is capable of playing audio files from a micro SD card, making it an ideal solution for playing custom audio messages in a doorbell system. With its compact size, low cost, and versatile functionality, the DF Player is the perfect addition to this project, allowing us to create a doorbell system that is not only user-friendly but also capable of playing custom audio messages for our visitors. For the storage of custom audio files, I am using a 4 GB SD card. However, it is not recommended to use a 4 GB card, as a smaller capacity card such as 1 GB would suffice. If possible, I would recommend using a lower capacity card as it would be more cost-effective and sufficient for the purpose of storing audio files. In my case, I was unable to obtain a 1 GB card and had to make do with a 4 GB card. In this project, I am using an audio amplifier module to amplify the output of the DF Player's audio signal. The DF Player comes with a built-in speaker output, which is not powerful enough for my needs. I am using a high-power speaker that I obtained from a damaged 55-inch LED TV. Although the speaker produces sound when connected directly to the DF Player's speaker output, the volume is not high enough. To increase the volume, I decided to amplify the DF Player's audio output. The DF Player comes with a left and right audio signal output, so I am using a TDA2030-based mono amplifier module. This module uses two TDA2030 ICs in bridge mode to provide high amplification. You can use any type of amplifier module, such as a Class D, but in my case, I am using this TDA2030-based mono amplifier module. The role of the tone control in this project is to increase the bass and treble of the playing audio files. While it is possible to set the bass and treble using software, I am using a hardware-based solution. The tone control is based on the BC548 transistor and comes in a stereo version. However, as we only need a single channel, we will only be using one of the two channels. It is important to note that the audio amplifier module and tone control module are optional components for this project. You can simply connect a small speaker without using these modules. However, I am using the TDA2030 and a tone control module to enhance the sound quality. Keep in mind that these modules are not necessary for everyone, but I personally chose to use them for improved sound output. For the complete project power supply, I'm using a 12-volt 2-amp transformer. The reason for using 2 amps is that I've added an amplifier module as well. If you're planning to build this project without the amplifier module, you can also use a 12-volt 1-amp adapter. I recommend using a 12-volt DC fan in all my projects that use a transformer. It is imperative to use a cooling fan with a transformer, as it helps to prevent overheating and extends the life of the project. By running a cooling fan in your device, you ensure that the transformer remains cool, providing a stable and long-lasting operation. In this project, I am using a small speaker that was taken from an old repaired 55-inch LED TV. Despite its compact size, the sound quality is excellent. There is no need to add any external amplifiers to the project as the DF Player module has an inbuilt amplifier that can easily handle it. However, I decided to use a third-party amplifier to enhance the sound quality even further. Finally, for the plastic enclosure, I'm using a slightly larger size box for this project. The reason for this is to provide adequate internal ventilation for the transformer and other components. With a larger size, I can easily fit all the components inside the plastic enclosure. If you have a 3D printer, you can make an enclosure for this project. However, I did not have the time to create a 3D printed enclosure, so I opted to purchase one instead. That's all, my friends. Now it's time to see the making of this NodeMCU doorbell system. It took a few days, but I have shot a video of the making process using an IP camera. I would like to share this video with you. Let's take a look at the process and then I will explain everything in detail. After completing this project, the final step was to place all circuit boards perfectly inside the plastic enclosure. I also installed a cooling fan on the top of the enclosure box. For our project, we have created 3 separate PCBs to ensure proper and efficient operation. These PCBs include the main control unit circuit PCB, the audio amplification control PCB, and the relay switching PCB. Let's examine each PCB individually. The main control unit circuit PCB houses the NodeMCU and DF Player, as previously mentioned. This PCB is responsible for controlling the doorbell system and playing the doorbell sound. The audio amplification control PCB is crucial in this project as it amplifies the audio signal from the DF player, ensuring that the doorbell sound is played at an adequate volume. This PCB integrates the TDA2030 module and bass and treble control module, and also features volume and bass and treble controllers. While potentiometers could have been used, this integrated solution was chosen to better regulate audio quality and minimize any potential distortion or noise. In this way, the audio amplification control PCB plays a crucial role in ensuring high-quality sound for the doorbell system. The relay switching PCB controls the activation of the doorbell system, such as when a doorbell button is pressed. This PCB uses a relay switch to control the power to the doorbell system, ensuring that it operates only when needed and conserving energy when not in use. I would like to explain the reason for using 4 relay switches in this project. Through this explanation, I hope to clearly demonstrate the role of the relay switches, making it easier for you to understand. In this project, the first relay plays a critical role. The first relay using in this project is to ensure continuous playback of audio when the doorbell switch is pressed. Without the use of the first relay, if the doorbell switch is pressed rapidly and continuously, the audio track would also play continuously, like this. This issue is resolved through the use of the first relay. The common terminal of the first relay is connected to the trigger pin of the NodeMCU doorbell system, while the normally closed pin of the first relay switch is connected to the doorbell switch. When the doorbell switch is pressed, the first relay is activated, and the connection between the doorbell switch and the NodeMCU doorbell trigger switch is broken. This allows the audio track to play uninterrupted, like this.
Unfortunately, all residents are currently away from the home.
Once the audio track is complete, the first relay switch turns off and returns to its normally closed position. As a result, the system is ready to be triggered again the next time the doorbell switch is pressed. The second and third relays in this project function using a changeover mechanism. Both relays are directly connected to the NodeMCU doorbell system, with their common terminals connected to the doorbell switch. The normally open terminals of the first and second relays are connected to the NodeMCU doorbell system, while the normally closed terminals of both relays are connected to the traditional doorbell. When the house owner turns off the doorbell system while at home, the 2 relays are deactivated and the doorbell switch resumes its traditional function. However, when the house owner is away from home, the NodeMCU doorbell system is activated and the second and third relays are turned on. This effectively changes the doorbell switch to the NodeMCU doorbell system trigger switch. The fourth relay serves a specific purpose in this project. Its role is to switch the amplifier module sections. Without the use of the fourth relay, if power is directly applied to the amplifier module, it would continuously operate and produce noise. To prevent this, the fourth relay is used to switch the amplifier module on and off only when the doorbell is pressed. I am using male header pins for all the PCBs. The header pins allow for easy connection between PCBs, which facilitates communication between the processes. This connector will be used to connect both the doorbell switch and the AC 230-volt connections, but I'm not sure what it's called. I purchased it from a local market and we can use any suitable connector for this purpose. I am using a 100 nanofarads disk capacitor for the NodeMCU DF Player and the main power supply to prevent noise or voltage fluctuations from affecting their performance. It is necessary to use this capacitor. I created a ventilation hole near the transformer inside the NodeMCU Doorbell controller to improve air circulation. However, I made the hole using a soldering iron, which can be very toxic and hazardous to health when used on plastic. In the future, I will look for safer methods to make holes in plastic. By separating these functions into separate PCBs, the doorbell system is able to operate more efficiently and with improved performance. The front interface of the doorbell system is designed for ease of use and functionality. It features a NodeMCU door system on-off switch, an audio track selection switch, and an LED light to indicate the selected audio track. The audio track selection switch can be any type of push switch, but in this particular design, a specific switch was chosen. This front interface allows the user to easily turn the doorbell system on or off, select a preferred doorbell sounds, and clearly see which sounds has been selected. The combination of these features makes the doorbell system user-friendly and convenient for daily use. The reason I added the track selection feature to my NodeMCU doorbell system project is due to a personal experience I've been facing. My workshop is located on the first floor and I spend most of my time there. Unfortunately, when visitors, such as customers, come and press the doorbell switch, I don't always hear the doorbell sound because of the noise from the running server fan in my workshop. This has caused visitors to think that no one is home. To resolve this issue, I added a track selection option with 2 audio message tracks. The first track plays a message saying that no one is home, while the second track informs visitors that the house owner is in the first floor. By doing this, I am able to ensure that visitors are aware of my presence even when I am in my workshop. Now it's time to build the audio tracks. Making the audio tracks is very simple. You can either record your own voice and save it to the SD card or download a specific MP3 audio file. In my case, I utilize a text-to-speech service for my needs. There are many free options available. I chose MicMonster's text-to-speech service as one of the best in its category. To create an audio message, simply follow these steps. Enter the desired text and select the language. Select the voiceover. And finally click Generate to convert the text. And then download the resulting file. Repeat the process to create a second track. Be sure to name each track properly so that the DF Player module can recognize them. Let's check the first audio track.
Unfortunately, all residents are currently away from the home. If you need anything, please return at a later time. Thank you.
And second audio track.
Ashwant is currently on the first floor. To reach him, simply take the stairs on the right and proceed upstairs. Thank you.
Additionally, it's worth noting that I will be using the Tamil language for my real-time audio message. This is the first Tamil track.
மன்னிக்கவும், வீட்டு உரிமையாளர் யாரும் வீட்டில் இல்லை. உங்களுக்கு ஏதேனும் தகவல் இருந்தால் பின்னர் வரவும். நன்றி.
And this is the second Tamil track.
மன்னிக்கவும், அஷ்வந்த் முதல் தளத்தில் இருக்கின்றார். வலது பக்க படிக்கட்டு மூலமாக மேல்தளத்தில் சென்று சந்திக்கவும். நன்றி.
Finally, I have set up a NodeMCU doorbell system in my room. The doorbell switch is located across the room, which is why I installed the system here. To connect the NodeMCU doorbell system to the doorbell switch, I am using a Cat5 cable. The cable has 8 cores inside, but for our connection, we only need 4 cores. Any kind of wire can be used to connect the NodeMCU doorbell system to the doorbell switch, but I chose to use a Cat5 LAN cable. I have set up the speaker here, along with all the necessary connections, including those for the doorbell switch and the speaker. Everything is properly connected to our NodeMCU doorbell system. I have turned on the device and selected the first audio track. The first track LED will glow to indicate that it is active. When I press the doorbell, the message track begins playing, but the doorbell switch will not respond until the audio is complete.
Unfortunately, all residents are currently away from the home. If you need anything, please return at a later time. Thank you.
I then switched to the second track and tested the doorbell switch again. The second audio message track also played when the doorbell was pressed.
Ashwant is currently on the first floor. To reach him, simply take the stairs on the right and proceed upstairs. Thank you.
However, during the audio playing time, the doorbell switch will not respond. After turning off the NodeMCU Doorbell system, I tested the doorbell switch once more and it worked as expected, activating the traditional doorbell. Thank you all for watching. If you have any questions or suggestions, please feel free to leave them in the comments section below or contact me in WhatsApp. My WhatsApp number is provided in the video description. Please note that I can only respond to messages, not calls. I am ready to reply anytime. Don't forget to like and subscribe to our channel for more exciting projects like this. Stay tuned for our next video, and until then, happy building!